Welcome back, everyone, to the deep dive. Today we're going to get into something really, really interesting.
I'm excited.
Yeah, so we are diving into a list of inventions that changed the world, and they all have one thing in common.
Okay.
You ready for this?
Yeah.
They all came from university labs.
Oh, wow. That's not something you hear every day.
No, it's not. We're digging into this document from the University of Virginia Patent Foundation,
Okay.
and it is packed with stories about brilliant minds and these, really unexpected discoveries.
It is pretty amazing how we always think about, you know, big companies when we think about innovation,
Right.
but it's like universities have been this quiet force shaping our world for centuries.
Yeah. And what's so cool is the variety of these inventions. We're
Yeah.
talking everything from life-saving treatments to just those little things we use every day, and we don't even think about it.
Right, right. The things we totally take for granted.
Exactly.
Yeah.
Okay, so let's start with a little time travel.
Sounds fun.
Back to Johns Hopkins University in 1879. Now I'm going to ask you a question.
Okay.
Have you ever used those little pink packets of saccharin?
Oh, yeah, definitely.
Well, guess what? That artificial sweetener didn't come from some big corporation.
Interesting. So where did it come from?
It was a total accident. This researcher, Konstantin Fallberg, he was working in a chemistry lab, and he noticed something weird.
What was that?
He had this sweet taste on his hands after a day of experiments.
Oh, wow. So he discovered it by tasting it.
Yeah, pretty much. He kind of went against what his advisor told him to do, and he just kept digging into it.
Uh-huh.
And that's how saccharin was born.
I mean, that's amazing. A rebellious researcher gave us one of the most popular artificial sweeteners.
Yeah. I wonder what his advisor thought about that later on.
Oh, I bet there were some regrets there.
Yeah, definitely. But think about the impact it had.
Mm,
Saccharin totally revolutionized the food industry.
that's true.
It gave people a sugar substitute if they had, dietary restrictions.
Right.
Of course, it also started all those discussions about, whether artificial sweeteners are good or bad for you.
Yeah, and those debates are still going strong today.
Right. It just shows how one discovery can, ripple through time.
Yeah.
It creates industries and starts important conversations.
That's fascinating.
So speaking of big impacts, let's jump ahead to the University of Toronto in 1922.
Okay.
This is where another huge medical breakthrough happened,
Uh-huh.
the isolation of insulin.
Oh, wow. Yeah.
This completely changed things for millions of people with diabetes.
It's true. Before insulin, diabetes was basically a death sentence.
It's hard to even imagine that now.
I know.
And the researchers behind it, Banting and Best,
Yeah.
they did something incredible.
What was that?
They sold the patent for just $1.
Wow. Why would they do that?
They wanted to make sure everyone could get this life-saving treatment.
Oh, wow. Talk about commitment to the greater good.
I know, right? Their selflessness made affordable insulin possible, and that's meant people with diabetes can live longer and healthier lives.
That's such an inspiring story.
It really is. But these early breakthroughs weren't just about medicine.
Oh, so there's more.
Oh, yeah. In the 1940s, we've got two grad students, guess where?
Toronto.
You got it.
Yeah.
The University of Toronto again, and they created the first practical electron microscope.
Wow. That's a big one.
Huge. This was a total game changer for science.
I can imagine.
Because before that, we could only see things with light microscopes.
Right. Limited by what you can see with light.
Exactly.
Okay.
But Albert Prebys and James Hillier,
Okay.
they use a beam of electrons instead of light.
Hmm.
And suddenly we could see things thousands of times smaller.
Wow. It's like getting a superpower all of a sudden.
Yeah. Like being able to see the invisible.
I wonder what it was like for scientists back then.
I know, right? Imagine suddenly seeing all those tiny details of cells and viruses, even atoms.
It must have been mind-blowing.
Completely. It was a massive leap forward, and it led to advancements in so many fields like biology and material science.
Really changed our understanding of the microscopic world.
For sure.
Yeah.
Okay, so we've got sweet discoveries, life-saving treatments, and a window into the invisible world.
This is amazing. What's next on our university innovation tour?
Let's shift gears a little bit and talk about how the digital age got started.
Right.
In 1946, the University of Pennsylvania unveiled the ENAC.
The ENA.
It was the first truly general-purpose electronic computer.
Wow. I've seen pictures of that thing. It was enormous.
I know, right? It took up a whole room and used thousands of vacuum tubes.
I can't even imagine trying to program that thing.
It was a huge accomplishment, though.
Oh, yeah.
It laid the foundation for the whole computer revolution that changed pretty much everything about our lives.
Yeah, think about it. The smartphones we use, the internet, even the way we shop and socialize,
Oh,
it
yeah.
all goes back to those first electronic computers.
It really makes you appreciate those early pioneers.
It does?
They had the vision to see what computers could do, even when it was all so new.
Yeah, incredible vision.
Speaking of vision, let's talk about medical imaging.
Okay.
Can you imagine a world without X-rays, ultrasounds, or MRI scans?
I mean, it's hard to picture that.
I know, but all of these amazing technologies came from university research.
Wow, that's right.
So the University of Vienna, they did pioneering work on ultrasound in the 1940s, which led to it being used for everything from, prenatal care
Yeah.
to checking for heart problems.
Right.
And then in the 1970s, researchers at Georgetown University developed the CCAT scan
Oh, yeah, the See It Cam.
that totally revolutionized X-ray technology.
Uh-huh.
It gave doctors this much clearer view inside the body.
That's amazing. And of course, we can't forget about the MRI scanner.
Definitely not. The MRI is like this incredible technology.
It is.
And the story behind it involves multiple universities and some brilliant minds.
Okay, I'm listening. Tell me more about that one.
All right, so the MRI, it's a total game changer for diagnosing all sorts of things.
Yeah.
From torn ligaments to brain tumors.
Right. I mean, it's used for so much.
But I've always wondered, how did it all come together?
Yeah, how do you go from a giant magnet to actually seeing inside the body?
Exactly. It's mind-blowing.
It's a really cool story, actually. It shows you how brilliant people can work together and achieve amazing things.
Okay, I'm intrigued.
So it starts with this guy, Raymond Damadian, at SUNY Downstate Medical Center. He's the one who actually built the first MRI scanner,
Wow.
and he got the fundamental patent for it.
Okay, so he built the machine, but was it actually taking pictures yet? Like, how do you go from a giant magnet to seeing what's happening inside the body?
That's a great question. It was another guy, Paul Lauterbur at SUNY Stony Brook, who figured that part out.
Okay.
He discovered that you could use changes in the magnetic field to create those detailed pictures we see now.
Oh, that's clever.
Right. So now we have the machine and a way to create images. So what's missing?
What else do you need?
We need a way to make sense of those images to actually understand what we're seeing.
Right. That makes sense.
And that's where Sir Peter Mansfield comes in.
Okay, and where was he working?
He was at Nottingham University in the UK, and he figured out how to make 2D imaging possible.
Oh, wow. So that's how we get those flat images.
Exactly. And he also developed ways to interpret those super complex MRI results.
It's amazing how it took a global team to make this happen.
Yeah, a true international effort.
3 different universities, 3 brilliant minds, all contributing to this technology that's helped so many people.
It's a perfect example of how innovation builds on the work of others. Each discovery opens the door for the next one.
Yeah, it's like a chain reaction of brilliance.
Exactly. And speaking of life-saving innovations, we can't forget about those amazing antibiotics that came out of university labs.
Oh, yeah. Antibiotics are a game changer.
Totally. They revolutionized how we treat infections.
It's hard to imagine what it was like before we had them.
I know even a small infection could be deadly back then.
Scary thought.
Yeah.
So tell me about some of those discoveries.
Okay, well, in 1939, researchers at Oxford University figured out how to mass-produce penicillin.
Penicillin, that's a big one.
It was a major breakthrough, and the timing couldn't have been better because World War II was just starting.
Oh, wow. So penicillin saved countless lives on the battlefield.
Absolutely. It was truly a miracle drug.
But universities didn't stop there, right? There were more antibiotics to come.
Oh, yeah. In 1943, Rutgers University gave us streptomycin.
And what was that used for?
That was the first effective treatment for tuberculosis.
Oh, wow. TB was a really serious disease back then.
It was a major killer, but streptomycin changed all that.
And then we have the polio vaccine.
Oh, yes, that's another huge one. In 1955, Jonas Salk at the University of Pittsburgh developed the vaccine that protected people from this terrifying disease.
I remember my grandparents talking about the fear that polio caused, especially for parents.
It's hard to imagine now, but it was a real threat.
I know it could cause paralysis and even death, mostly in children.
And Salk's vaccine marked a turning point in the fight against polio.
It eventually led to it being almost eradicated in many parts of the world.
It's incredible. Another testament to the power of university research.
Okay, so we've talked about fighting infectious diseases, but what about other areas of medicine, like surgery?
Oh, yeah. Universities have made some huge contributions there, too.
Like what?
Well, for instance, in 1955, researchers at the University of Minnesota developed the heart-lung machine.
Oh, wow, the heart-lung machine. That made open-heart surgery possible.
Exactly. Before that, it was just impossible to operate on a beating heart.
That's wild. It's amazing to think that something as common as open-heart surgery was basically science fiction not that long ago.
It really shows how far we've come.
So universities have tackled these major life-threatening diseases, but they haven't forgotten about those everyday health concerns that can really affect how we live.
You're right, they've been working on those too.
Give me some examples.
Well, how about chronic dry eye? It affects millions of people.
Oh, yeah, I've heard of that.
In 1983, the University of Georgia developed Restasis.
Okay.
It's a low-dose cyclosporin that helps treat dry eye, which can be a really uncomfortable and debilitating condition.
Interesting. What else?
Oh, and there's adenocard from the University of Virginia in 1985.
Adenocard, what does that do?
It's used a lot in emergency rooms to treat something called supraventricular tachycardia,
Okay.
which is basically a dangerously high heart rate.
Oh, wow. So it's a lifesaver.
Absolutely.
So we've seen how university research has impacted so many parts of our lives.
It's true, from treating serious diseases to helping with everyday health issues.
And it's not just about humans either.
You're right, we've benefited, but so have our furry friends.
Exactly. University researchers have developed vaccines for our pets, too.
Oh yeah, like the canine parvovirus vaccine from Cornell University in 1979 and the kennel cough vaccine from Iowa State University.
Those vaccines have saved so many dogs' lives and given peace of mind to countless pet owners.
It's true. It's a reminder that innovation isn't just about us. It's about improving the lives of all living things.
Well said. But let's not forget about those inventions that are less about life and death and more about making our lives more enjoyable.
Okay, I think I know what you're going to say. Are we talking about Gatorade?
You got it. It's hard to believe that this famous sports drink actually came from a university lab.
I know, it's a classic story.
So back in 1966, researchers at the University of Florida developed Gatorade to help their football team, the Gators, stay hydrated and energized during those hot Florida games.
And it worked. The Gators won their first Orange Bowl that year.
Wow.
And Gatorade just took off. It became a staple in locker rooms across the country and eventually the world.
From a university lab to a multi-billion-dollar industry, it's an amazing story of innovation and entrepreneurship.
It really is. But there are other examples too, like Tifway Tifgreen and all those other Tif grasses.
Oh yeah, I've heard of those.
They came from the University of Georgia, and they're Bermuda grass hybrids that you see everywhere.
Really, where?
On golf courses, athletic fields, and lawns all over the U.S.
Oh wow, that's interesting.
They're really durable, disease-resistant, and pretty low maintenance, which makes them perfect for all sorts of uses.
So the grass on my golf course could be from a university research project.
It's very possible. But you know, one of the biggest lessons we can learn from all these innovations is the power of collaboration.
Yeah, that's a good point. We've seen researchers from different universities, different fields, even different countries, all working together.
Exactly. They come together to solve tough problems and push the limits of what's possible.
Like with the development of the combination PTCT scanner.
Oh, yeah, that's a great example.
So the initial idea for that came from Ronald Nutt and David Townsend when they were both at the University of Geneva.
Interesting.
But then they continued their research at the University of Pittsburgh, and that's where they developed a working prototype in 1998.
Wow, and then it got FDA approval in 2000.
Exactly. And that combination of PT and CT technology gave us the first medical image that had both anatomical and metabolic data from a patient.
Which means?
It meant doctors could see the location of even tiny tumors and lesions with incredible accuracy.
Wow, that's a real breakthrough.
And it's all thanks to the power of collaborative research and how science really is a global effort.
It's amazing how these collaborations can go beyond borders and different areas of expertise.
They bring the best minds together to tackle some of the biggest challenges we face.
It's inspiring. But these collaborations don't just benefit patients and people who use these inventions.
Oh, that's right. They also have a big impact on the universities themselves.
You know, a lot of these inventions have brought in a lot of money for the universities that developed them.
Like what, for example?
Well, take recombinant DNA technology, for instance.
Okay.
It was developed at Stanford University and the University of California, San Francisco back in 1974.
Okay.
And it's been licensed to over 200 companies.
Oh.
And it's played a huge role in the growth of the entire biotechnology industry.
That's amazing. It shows you that university research isn't just about learning more.
Right.
It's also about boosting the economy and encouraging innovation and entrepreneurship.
Absolutely. And as we've seen from all the inventions we've talked about today, universities have been and continue to be at the forefront of these incredible discoveries that shape our world.
It really makes you wonder what's happening in those labs right now.
Yeah, what amazing projects are going on that could lead to the next big breakthroughs.
Maybe there's some grad student somewhere hunched over a microscope and they're about to have that aha moment that changes everything.
It's exciting to think about.
And it all starts with that curiosity, the drive to understand how things work, and the desire to make the world a better place.
Yeah, it really is a beautiful thought, isn't it? All these amazing discoveries waiting to be made.
And the best part is they can come from anyone, anywhere.
Right. It doesn't matter who you are or where you come from.
As long as you have that passion to explore and to innovate.
That's the key. And it's like this incredible relay race of brilliance.
I love that analogy.
Each generation builds on the knowledge that was passed down from those who came before.
It's like we're all part of this grand story of human progress.
Exactly. And every single discovery, big or small, adds to that story.
It's humbling to think about all the people who are working hard behind the scenes to make these discoveries happen.
It really makes you appreciate the power of research and education.
Yeah, we need to support those curious minds out there and give them the tools they need to explore, experiment, and innovate.
Absolutely. Who knows, maybe the person who figures out clean energy or cures Alzheimer's is out there right now just waiting for their chance.
That's why it's so important to invest in universities and their research efforts.
We need to create those spaces where breakthroughs can happen.
Spaces where collaboration is encouraged and failure is seen as a step toward success.
Exactly. We need to embrace that spirit of exploration and discovery.
So what does all this mean for our listeners? It's a call to action. Stay curious, stay engaged, and never stop learning.
That's the best advice you could give. You never know what incredible discoveries are just around the corner waiting for someone like you.
The world needs more curious minds, more innovators,
Yeah.
more people who are willing to push the boundaries.
And if you're feeling inspired by all these amazing inventions that came from universities and you want to be a part of that world-changing work, guess what? There's a place for you.
Absolutely. And if you're thinking about jumping into the world of higher education research, there are so many opportunities out there.
Where can people find them?
You can check out academicjobs.com.
Oh, yeah, I've heard of that site.
They have listings for research and science positions in all sorts of fields.
That's great. So many options to explore.
You might even find yourself working in a lab that's on the verge of the next big breakthrough.
It's exciting to think about.
So go out there, explore, discover, and innovate. The future is waiting for you.
That's a great way to put it. The future is in your hands.
Until next time, keep diving deep and keep those brainwaves buzzing.